DeBacco University video. I'm going to be discussing the elements we see on this slide, which comprise the alkaline earth metals found in group 2 on the periodic table. So as alkaline earth metals are group 2, they're found in that second column of the S block of the periodic table immediately to the right of the alkali metals. They have 2 valence electrons and have a tendency to form a +2 cation, and they are reactive, but less so compared to the alkali metals. Now here we can see an example of the alkali metals. They do have a comparison that, again, while less reactive than these alkali metals, or alkaline earth metals are, they are still reactive with water. And they are least reactive at the top and increase their reactivity as we go down the family. This same thing can be said for our alkali metals, this same thing for the ones we're talking about here, the alkaline earth metals. But in comparison, those alkali metals are going to be the most reactive, but still we see this same pattern that repeats itself. Least reactive at the top, most reactive at the bottom. Beryllium is an exception for alkaline earth metals. That one is relatively unreactive due to the oxide layer that it does produce. Now the position in electron configuration, each alkaline earth metal has 2 valence electrons in their outermost s-orbital. So beryllium, magnesium, calcium, we could see 2, 2, and 2. Those valence electrons, the 2 s-electrons are responsible for their chemical reactivity as they are lost to form a stable +2 cation driven by the octet rule. And this allows us to be able to go through and have some degree of reactivity because it's got to get rid of 2. But a little less reactive than those alkali metals that are just trying to get rid of 1 pretty violently. Some unique features and uses for our alkaline earth metals are that they're harder and denser than our alkali metals, higher melting points than group 1, and they're used, for example, calcium in bones as well as construction related to concrete, so physical structures as well, and magnesium in airplane parts and flares. So we could see there's many uses for these, typically in a combination form, maybe not necessarily their pure form, but in some cases here we see where their pure forms can be very advantageous and something we may require and something we may interact with on a daily basis.